What if black holes are dark energy? Sounds weird, but stick with me. First off, let's explain what these two things are. So dark energy is the name we give to whatever it is that's accelerating the expansion of the universe. The universe is getting bigger at a faster and faster rate. We don't really know why, and we call the thing that's making it happen dark energy. Black holes are objects that are so dense, their gravity is so powerful that not even light can escape. The classic model for a black hole has an event horizon, the point of no return, and a singularity, a spot of infinite density, or maybe just a spot where our mathematics breaks down. And you can mathematically derive black holes from general relativity in a few different ways. If you assume it's not rotating, you get something called a Schwarzschild solution. If you assume it is rotating, you get a Kerr solution. But there are other solutions, including solutions without a singularity, so-called non-singular black holes. And this is where things get really weird. There is an idea that as stars collapse to form black holes, their matter is converted into vacuum energy. This is kind of a weird concept. It's essentially just the energy inherent in space itself, but you can think of it as inside a black hole, you've got an energized vacuum, and that's it. That's what makes up the black hole. The mathematics of this works really well, and from an external perspective, we actually wouldn't be able to notice any difference from black holes as we traditionally think of them. But there are some interesting consequences, because these black holes could become what's known as cosmologically coupled, which means as the universe expands, black holes grow. They're linked, they're coupled. And in order to conserve energy while these black holes grow, you need a negative pressure. That is what dark energy is. It's negative pressure. It's pushing stuff out. Therefore, black holes are dark energy. But there's a but. See, A, that mechanism of black holes coupling to the expansion of the universe and that in turn causing negative pressure is not at all understood. And B, we don't really have any astronomical evidence that black holes are like this. This week, a new paper came out suggesting that these models could explain the new DESI results, the ones that say dark energy is actually changing over time, which is not at all our standard model. But there are still a lot of other ways this dark energy black hole model needs to be tested, and it just hasn't happened yet. We'll just have to wait and see what happens.